In a previous video where we introduced the tabular data processes, we talked about how RAMP expects and requires standardized ASCII CSV format data when it's working with tabular information. So in this video we're going to look at how we actually standardize various ASCII data files into the format that RAMP expects and requires. So if I click on the tabular data processor, you'll see the first four methods here are methods that are focused on standardizing ASCII data into the format required. And they allow you to work with delimited text in ASCII, ASCII fixed width column data, XML data, and JSON data. So we're going to look at each of these in the video. Let's start by looking at a ASCII file in the Ascii Data Inspector that is delimited but not in the required format. So I'm going to open my sample file here, example delimited data. Okay, and you will see that it has a couple of lines here at the top. It appears to have some hashed or comment lines that appear to describe the various fields in the data set, and the data records appear to be, the columns appear to be delimited by the pipe symbol here, and the rows appear to be delimited by line, which is good. So this is clearly not a standardized ASCII CSV file, and if I try to read it as a standardized ASCII CSV file, you'll see what happens here. Where's that file going again? Here it is. Okay, it's read the first line, figured that that was the header, and then it's read all the other lines following that, but it hasn't been able to split them up and delimit them because it doesn't understand the pipe symbol. So let's look at a processor. I'll open this back up in here again. Let's look at a processor that allows us to standardize this particular file. So we'll go back to the tabular data processes, and we'll choose the first method, which is standardize ASCII delimited data, because this is delimited data, it's just not in the format that we want it to be. So I'll pick that input file again. Okay, the first thing it's asking me is skip header lines. So that's the number of lines before the actual data starts. In this case there are two, because we'll consider these hashed lines to be comment lines that can occur anywhere within the file. So we'll say skip 2 header lines. Let's change that to 2. And then it says, do you have a header for the fields on any particular line? Well, we do kind of have a header for the fields, but they're in these comment fields and they're not on one line. So we'll leave that as 0. No, we don't have a header line. And then it's asking for, okay, well, provide me with a header line. So we can use the fields that they've described here, and basically what we want to do is tell RAMP what the first line of the output standardized data set will be. So we'll give it that. Distance offset x, y, value. That's the header that I want to write at the beginning of my standardized ASCII CSV file. Then it's asking me, do you have any comments in there? Yes, we do, and it's a hash. And the delimiter that we're looking at is actually a pipe symbol. And now I will choose my output file. I'm going to overwrite the one that I did in practice and run. Okay, it's done it. Now let's look at that particular file that we just created. Okay, that's better. You can see it's got the header that we gave it, and everything appears to be delimited by commas now. Let's open it in here and see that it works properly. And perfect, beautiful. Nicely standardized ASCII CSV file. So that was an example of standardizing ASCII delimited text. What if we had a file that wasn't delimited by a character and was in fact delimited by, say, columns or spaces? So I'm going to open this data set here. This is a bathymetric data set from the Japanese government for the Japan Sea that I downloaded from their website. And just inspecting it, we can see that we have what appears to be some sort of flag in this column, and then a number of spaces before what appears to be the latitude and longitude values, and then over here we have the actual bathymetric depth value. So we can use the standardize ASCII fixed width columnar data method in the tabular data processor to read this file. So let's look at that. Firstly, I'll tell it where the file is. It's that file there. Now it says skip header lines. Well, I don't appear to have a header line, so I'm going to say nope, don't skip a header line. Then it asks me the same question. Do you have field headers on any particular line? Well, no, I don't. There's no field headers in this. So give me the field header. So I'm going to say, okay, we've got a flag field, what appears to be the latitude, the longitude field, and then a depth field. That's what I want it to write. Are there any comments? There doesn't appear to be. I'm going to leave it as hash anyway, just in case there is. Now what we need to do is we need to tell it how to map the columns into the output file. So this is essentially a comma-separated string that defines the columns to read in the input file. So in the preset example, it says read columns 1 to 10 and read columns 11 to 20 as the two output fields. We need to create 4 column mappings in here. So that's why I've got the inspector up here. So let's have a look. I'd say column 1 to column 2, because the Ascii Inspector gives us a nice readout of the lines and columns we're on. So I'll highlight what I want to import in there. It says that's column 1 to column 2. Sorry, column 1 to column 2. So the first one will say column 1 to column 2. Then the latitude appears to be column 4 to column 11. So 4 to 11. The longitude appears to be column 13 to 21. And the last one appears to be 26 to 27. But I need to be careful here because you'll see it gets bigger here. And if we go to the end of the file, it's still in the range of 3 characters. So what we could do is we could read 25 to 27, but to be careful, we might read a wider range. So let's read 23 to 27. Characters 23 to 27. That's how I want you to map it. Okay, let's choose the output file. So geodc blah 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 blah, and this will be the CSV file version. CSV. Okay, let's run it, see what happens. Okay, it's done. Let's read that newly created file. That's my CSV file. Looks like it's done a good job. It's read the flags, latitudes and longitudes correctly, and it's captured the depths correctly. Let's double check by reading it into here. Yeah, nice. Okay, so there we have used some fixed column ASCII data and imported it into a standardized ASCII CSV file. Now, what if I had some XML data? Let's look at that. Let's look at that eventuality next. Okay, so in my web browser, I have a REST API that I can call that returns an XML file that gives me the position of various assets at particular points in time. So this is returning XML serialized data from this REST API. And you can see that it has a series of these datagram XML nodes that contain various attributes, including the latitude and longitude. So we're going to use this as the XML that we want to be able to standardize into an XML file. So into a standardized ASCII CSV file. So we need to map the XML structure to the output ASCII CSV file. Let's look at how we do that. So the ramp documentation for the map XML method gives you some examples of an input XML file and then how the output field mappings might work. So when you want to import an XML file to a standardized ASCII CSV file, you need to create what's called a mapping file that explains to the method, the processing method, how to convert the XML into a standardized ASCII CSV file. And essentially, the mapping file starts with read all of the XML nodes called item, and then map, these are the output ASCII CSV names, map this subnode or sub attribute, or sorry, node attribute to this field. And it uses simply dot notation to work down through the XML structure. So in the example here, output field n get item, so the first item is this, and it's saying field n get the name. So it's gone to item, it's said, oh, there's an attribute called name, I'll use the value of that attribute. Then it said go to geometry. Okay, I'm in the item, there's a subnode called geometry, and get the x attribute. And then for the y field, go to the geometry and get the y attribute. For field value, go to the value node, and dot star indicates that you need to read the inner text of that node. So in that case, the inner text is between the two value XML nodes, and it's 22. And then this notation here says, okay, for field N1, go to the email subnode and use the first email subnode. So in this case, it's email email child node at index 0 and get the description attribute. So that would be, that's the first one, or index 0, description, done. And then subsequently it says here to go to the next email subnode or child node, which is this one, get the description and get the get the inner text. So these are the main ways. So mapping field is fairly simple. You just need to understand the dot hierarchy, the use of the asterisk or star for returning the inner text of a node, and then the use of the colon dash index number when you're referring to potentially multiple instances of a child node, and getting the specific index of that one. So that's how the mapping file looks, and that's how it's documented. And we will now look at our example of the XML API and map that structure to a mapping file. So let's have a look at that. Okay, so this one's quite simple. We need to remember the first line is an instruction of which nodes to get. So we want to get all of the datagram nodes within this XML file, and then we're going to create a field called ID, and it will simply be the ID attribute of the datagram. So here's the ID attribute, POSIX, latitude. So it's going to be very easy for us to map this because we're simply doing this. POSIX equals POSIX, latitude equals latitude, longitude equals longitude, heading equals heading, rate of turn equals rate of turn, speed over ground equals speed over ground, course over ground equals course over ground. So this is our mapping file. Let's save it. XML mapping.txt. Okay, we've got our mapping file. Let's go back into ramp. Okay, we'll launch the processor and we'll choose the map from XML data. This is asking us for the URL. So the nice thing in ramp is that I can actually give it the REST call, the REST URL, and it will make that call to the API and get the XML and then process it. So I don't have to have pre-cached the XML data. I can actually point it to a REST API endpoint. Okay, our mapping file is XML mapping.txt. It's going to look for an output file, so I'm going to call it vessels.csv because this is data for vessels and boats, and append. Okay, creating output file, done. Let's go have a look at what this file looks like now. So let's open it here. And you will see that indeed it has mapped all those fields correctly. If I open it in the standard ASCII CSV viewer, yep, everything has been nicely mapped across. So it's a very simple way to take XML data and convert it into a standardized ASCII CSV file. Now let's look at JSON data. So JSON is the JavaScript simple object notation, and this API also has the option for returning JSON. So we will use this, and let's look at how we convert JSON to standardized ASCII CSV in RAMP. So I will load the Tabular Data processor, and you'll notice there's a method in here called convert JSON to XML. So unfortunately, RAMP doesn't convert JSON directly to ASCII CSV. It expects you to serialize the JSON as XML and then do subsequent processing on the XML. But again, I can point it to the URL, and I can point it to an output file. So we're going to create vessels.xml as the output file. Let's run it, and then let's have a look at that output file. So vessels.xml, let's have a look what it created. So a little bit different from the XML that we got from the REST API. You'll see that it's a bit more verbose. It's serialized the datagrams as an array, and each item or datagram is now referred to as an item within that datagrams array. So the XML mapping is going to look a little bit different. Let's see how that might have changed. So here is my previous XML mapping. Now let me move that over here. Now I'm not looking for the datagram node in the XML, I'm looking for the item node. So with this will change to item. And then underneath the item, I want to go to the ID node next and get the inner text. So this is going to be pretty simple. I just need to say ID node inner text. So that's that dot asterisk dot star notation. Heading, longitude. So that's really the only change I needed to make to my mapping file. Let's just save that. Okay, and now let's run the same XML mapping. So in this case, the path has changed because it's now an XML file on my local machine. The mapping file will be the same, XML mapping, we just overrid it. And the output file will also override this, vessels.csv. Okay, it's run. Let's have a look at what it created. And it's created pretty much exactly the same thing. Let's double check that in here. Excellent, it's done a great job. So to convert from JSON, we have to take the JSON to XML and then apply the XML mappings to standardized ASCII CSV file. So they're the four main methods in RAMP that allow you to standardize different data structures. We'll probably introduce others in the future, but those are the ones that are available in RAMP at the time of this video. So I hope it's been of use to you. Thanks for watching.